Hello guys and welcome back. I hope you guys had a good Easter break. I'm going to be presenting my free response question from the 2014 AP exam, question number 5. So, some binary compounds that form between fluorine and various nonmetals are listed in the table above. A student examines the data in the table and poses the following hypothesis. The number of F atoms that will bond to a nonmetal is always equal to 8 minus the number of valence electrons in the nonmetal atom. Based on the student's hypothesis, what should be the formula of the compound that forms between chlorine and fluorine? So based on this hypothesis, the formula should be ClF. ClF. Because Cl has 7 valence electrons, and following this hypothesis, 8 minus 7 is equal to 1, so one F atom will bond to the nonmetal Cl. So that's question part A of number 5. Alright, part B. In an attempt to verify the hypothesis, the student researches the fluoride compounds of other halogens and finds the formula ClF3. In the box below, draw a complete Lewis electron dot diagram for a molecule of ClF3. This will look like so. So the Cl central atom is surrounded by 3 non-bonding pairs with F atoms and two non-bonding or lone pairs of electrons. F atoms must have 3 non-bonding pairs each, as depicted by the dots and line segments. Alright, part C. 2 possible geometric shapes of the ClF3 molecule are trigonoplanar and T-shaped. The student does some research and learns that the molecule has a dipole moment. Which of the 2 shapes is consistent with the fact that the ClF3 molecule has a dipole moment? Justify your answer in terms of bond polarity and molecular structure. So, the student finds out the ClF3 has dipole moment. The shape that is consistent with this piece of information is T-shaped. This makes sense because the T-shaped structure is asymmetric with dipoles that don't cancel out, but produce a net dipole like a polar molecule. If the molecule had trigonoplanar structure, on the other hand, the molecule would be symmetric with dipoles that cancel out and produce a net dipole of 0, which is not consistent with the observation of a dipole moment, as symmetry would not create polarity. That is part C. In an attempt to resolve the existence of the ClF3 molecule with the hypothesis stated above, the student researches the compounds that form between halogens and fluorine and assembles the following list. Based on concepts of atomic structure and periodicity, propose a modification to the student's previous hypothesis to account for the number that form between halogens and fluorine. Okay, so an acceptable hypothesis would be that as the atomic number of the essential halogen atom increases, atomic number increases, the number of F atoms increases. As you go down a group, the formula is increased by 1. Alright, that is all of question 5 from the 2014 exam. I hope this helped, and once again, make sure to leave a like, subscribe if you will, and comment if you have any questions. Thank you.